Cool.
Let me do this. Let me blow that up.
Okay.
Take a picture of it. And then I can graph it.
Cool.
Yeah, this new capability is really working out nicely.
Nice.
Yeah, especially on problems like this, where they give you a grid, keeps me from having to draw the grid.
Right. Saves a lot of time.
What's the parent function here?
Would it just be y equals
That's it, right there.
that's it? Okay. Okay.
That is an exponential function.
Okay.
As long as that number is greater than 1, then it's going to look like this, regardless of what it is.
Okay.
I could say y equals 7 to the x, and you wouldn't be able to tell. That would still look like that.
Okay.
Okay? So the base is not important. What's important is that it goes through this point,
Plus 1.
0, comma 1.
Uh-huh.
Notice that if I make x 0, y is always 1, no matter what the base is.
Okay.
Okay, so the original function looks like that. The parent function.
Okay.
What's the difference? What's happening to this function?
It's 2 to the x. So
What's the only thing different between this function and our parent function?
the plus 1.
What's the plus 1 do?
It vertically shifts it up 1.
Okay, so the only point that I know here is going to go where?
0, so 2 to the 0 plus 1. 1 is equal to 2.
There. It's going to go at 0, comma 2.
Okay.
In other words, the graph of the function that we want is going to look very similar to the parent function, except it's going to go through the point 0, comma 2. Because if you plug in 0 into that function, you get 2.
Okay.
So the only real thing it does is moves the horizontal asymptote up 1 unit.
Okay. Cool.
But,
So the domain.
yeah, how about number 2?
Okay.
The parent.
What about like the domain range of the transformation? So like.
Sorry.
No, you're good. You're good. So
we're going through 2. We have a horizontal asymptote at 1.
Right.
In other words, the horizontal asymptote of the parent function was y equals 0.
Right.
The moment you have this vertical shift up 1, it moves the horizontal asymptote up 1 also.
Okay.
So what's the domain?
So will the domain be 0, comma 2? Since it moves it up 1, or just element of all real numbers.
Listen, when you are talking about domain, I want you to look horizontally, not vertically. I want you to look horizontally.
Okay.
Do you see why it's all real numbers?
Because it could be any number on the graph.
On the x-axis, not on the graph. It's very important to distinguish between the x and the y-axis.
Okay.
Notice what the available numbers are on the x-axis. They are not limited at all. There is no value for x that you could not put in.
Okay.
And that shows on the graph. In other words, it comes all the way from negative infinity and eventually it goes to positive infinity.
Okay.
On the x-axis. But make sure you look at the graph. That's where you get your range and domain from.
Okay.
What's the range?
Y is an element of all real numbers.
You see any negative y's?
Um, it could be negative, right?
Well, do you see any negatives?
Not on that, no.
Well, there aren't any.
No.
In other words, it never goes below that horizontal asymptote.
Okay.
So the lowest value of y is 2.
Okay. Gotcha.
What's the
So,
range?
y is greater than or equal to 2.
Good.
Cool.
What transformations?
Vertical shift up 1.
All right. Let's go to the next one.
Cool.
I can't emphasize enough that when you are looking at domain, you are looking horizontally.
Okay.
You're not looking vertically at all. You're looking horizontally only. When
Okay.
you're looking at range, you're looking vertically only.
Okay.
You're not looking horizontally at all.
Mm-hmm.
Okay? What's the parent function on number 2?
Y equals 4 1/2 x minus 1.
No, just 1/2 to the x.
Oh, okay.
Okay? Everything
Okay.
else you see is a transformation.
Uh-huh.
Now the question is, what does y equal 1/2 to the x look like?
Uh-huh.
The last function looked like this. What does this look like?
This looks, well, yeah, it looks like the previous one.
Not really.
Right.
When this number is less than 1,
Okay, then it's, okay.
then it's a decaying function. Notice that 1/2 times 1/2 is 1/4.
Okay.
Multiply it by another 1/2, it's 1/8. If I multiply it by another 1/2, it's 1/16. In other words, it's decreasing, always.
Okay.
And in fact, I didn't quite draw it right because it also goes through that point. It just goes through it. And it still approaches the x-axis. Now, what I've drawn on there is the parent function only. What's the domain on the parent function?
That makes sense.
Let's not talk about the parent function. Let's talk about the adjusted function. There's 3 things going on here. That, that, and there's that. What's the 4 do?
Horizontal shift, right 4.
Well,
Right.
outside the function. Anything outside the function is vertical.
Oh, okay. And then inside's, okay. Then horizontal.
Well,
so it would be
you understand what I mean by being outside the function.
Oh, I understand. Yeah, no, yeah.
In other words, it's not in the parentheses. If the function is that, well, then I need it to be inside the parentheses to be a horizontal transformation. Anything outside the parentheses is a vertical transformation.
Okay.
What does the 4 do?
So it'd be a vertical shift up 4.
It's a vertical stretch.
Oh, stretch, okay.
And that matters by 4. They're not the same as a vertical shift.
Okay.
That 4 means that every value that I would have had is now 4 times bigger.
Okay.
So this point that was at 0, 1 now is there. Just by virtue of that.
Right.
Now, the second transformation. What is that? Is that horizontal or vertical?
Vertical.
Nope, it's inside the function.
So it'd be horizontal.
Inside the function is horizontal.
Okay.
Hold on a second. I think we need to back up a little bit here.
Yeah.
You're not going to get this with... I'm going to take this function.
Okay.
And I'm going to transform it in the 6 possible ways you can transform it.
Okay.
The first 3 are going to be vertical.
Uh-huh.
What's that do?
So now it'd be a vertical shift down.
Hold on. Negative signs mean reflections.
Okay.
So what does that negative sign do?
Reflects it over the y-axis.
No, it's a vertical shift. Excuse me, it's
So over the
a
x.
vertical reflection.
Okay, so it'd be over the x.
Yeah, if e to the x looks like that,
Uh-huh.
this is a vertical reflection. It makes it look like that.
Okay.
I call that a vertical reflection. Some people call it a reflection over the x-axis, but to me, because it is outside the function, it is a vertical reflection.
Okay.
All transformations that are outside the function are vertical.
Okay.
It's as simple as that. That's the easiest way to remember.
That is easy.
Transformations that are inside the function are horizontal.
Okay.
Okay, so that was vertical.
Okay.
That.
Okay. So that would be vertical, vertical stretch up to.
Good. Vertical stretch by a factor of 2.
Okay.
This changes the shape of the function.
Uh-huh.
No longer looks like that, it looks steeper.
Right.
But it's vertical because it's outside the function.
Okay.
Now, tell me what this is.
A horizontal shift, right 3.
Inside or outside the function?
Wait, it'd be outside, so it'd be vertical.
It's vertical. If it's outside the function, it's vertical. And that's the way I want you to remember it.
Okay.
Because there's only 3 verticals and 3 horizontals. So rather than remembering 6 things, you're really remembering 3 things at a time.
Right.
You just have to distinguish whether it's inside or outside the function. Well, clearly that's outside the function.
Right.
That is a vertical shift up 3.
Up 3. Okay.
Okay?
Cool.
Now, let's talk about horizontals.
Okay.
That is the equivalent. Notice why that is inside the function.
Uh-huh.
Because the negative sign, that's f of negative x. When I say inside the function, that's what I mean. If f of x equals e to the x, then f of negative x equals e to the minus x. So that's what makes it inside the function. So is this horizontal or vertical?
Okay, that makes sense. So this would be vertical. I mean horizontal. It would be horizontal.
Horizontal reflection, meaning reflecting over which axis?
Y-axis.
So instead of looking like this, looks like this.
Yeah.
Okay.
Okay. Okay.
The other 2 horizontals you can do are that's inside the function, right?
Right.
And it's subtraction. It's not multiplication. So what is that?
So it'd be a horizontal, would be stretch, or not shrink, horizontal shrink.
You got stretches, shrinks, and shifts. They're hard to distinguish because they all start with S.
Yeah. So it'd be a horizontal shrink.
Shift. Because it's minus 2. If it was e to the 2x, that would be a shrink or a stretch, but it's a shrink.
Okay.
If you're adding or subtracting, like we are here, then it's shifting.
Okay.
Notice that when I said, what is this? That was adding. That is a vertical shift. Now,
Okay.
when you're adding or subtracting outside the function, it's a shift. Even if it's inside the function, it's a shift. If you're adding or subtracting, it's a shift. And what that means is it does not change the shape of the curve. It just moves it over.
Okay.
All right? So that is a horizontal shift. Which way?
Right 2.
Okay, right 2. And the only other horizontal thing you can do is something like that. What does that do? Notice why that's inside the function. That is f of 3x. That's what makes it inside the function. And what does that do?
And then that's a vertical, a horizontal shrink or stretch.
It's actually a shrink.
Okay.
In other words, when you're going horizontal, if that number is greater than 1, it's a shrink. When you're going vertical, if that number is greater than 1, it's a stretch. So it depends on whether it's vertical or horizontal as to what it is. But that's it. That's the only 6 things you can do to a function. You can do 3 vertical things or you can do 3 horizontal things. And the biggest thing to remember is that negative signs mean reflections. Adding and subtracting means shifts. Multiplying means shrinks or stretches. That's it. So, let's go back to your problems here. Number 2, I don't think we finished it. Y equals what is the parent function?
1/2 to the x.
What's happening to this? What? 3 things. In other words, you got that, you got that, and you got that. The first one, what does that do?
The 4, since it's on the outside, it'd be a vertical shift of 4.
Stretch. It's multiplying. It's not a shift. The -2 is a shift because it's being subtracted. Remember, when you're multiplying, it's a stretch or a shrink. So that's a stretch by a factor, stretch by 4. What's this x minus 1 do?
And then the x minus 1
First of all, mean horizontal or vertical? Answer me that.
Horizontal. It's on the inside of the...
Inside, okay. Is it a shift or a stretch or shrink?
Stretch.
Hold on, it's being added or subtracted. Those are always shifts.
Which means shift, okay. And then multiply means it's being stretched, and then
or
shrunk means... Or shrunk, yeah.
Yeah, that's the hardest one because it depends on whether it's horizontal or vertical, whether it's a stretch or a shrink. But the shifts are always the same. A horizontal shift which way?
So it'd be a horizontal shift, right 1.
And finally, what's the -2 do?
Which means it's being
vertical or horizontal?
Vertical.
Shift or stretch?
Shift.
By how much?
Left 2. Right 2.
First of all, if it's vertical, it's not left or right.
It's for
up or down?
Yeah, so up. Up 2.
-2 is up?
Down 2. God, my bad. Yeah, down 2.
That's the 3 things going on. So that makes it easy to graph because here's the original parent function. Going through that key point, which is 0, 1. They all go through that. And now to do all of these, well, let's do the shifts first because they don't do anything to the shape of the curve. So if I'm shifting this 1 to the right and 2 down, what happens to that point right there? Where does it go?
So if it's first shift down 2 and then right 1 you said?
Uh-huh. That's based on that. That's right 1 because of that, and it's down 2 because of that.
So it'd be negative 1, 1, or 1 comma negative 1.
Right. 1
Okay.
comma negative 1, which is right
Okay.
there.
Yeah.
Okay, so that's a shift to the right of 1 based on
Yep.
that, and a shift down of 2 based on that. So this point is going to go to right there.
Okay.
Where was the horizontal asymptote on the parent function?
Horizontal asymptote.
Yeah, y equal what? On the original function. Now look at the original function, the black line.
Right.
What is that asymptotic with?
Oh, that's my bad. So it'd be y is equal to 0 comma 1.
Just 0.
Just
The
0.
equation of a straight line is y equals 0, a horizontal line, or x equals some number for a vertical line.
Okay.
It's not a point. It's a line.
Okay.
In other words, there's the line, y equals 0.
Okay.
That original function is asymptotic with that line.
Okay.
Now, the fact that we moved it down by 2, what's the new asymptote?
So since it's down 2, it'd be y equals 1.
What's down 2 from 0?
Negative 2.
Then that's the new asymptote.
Okay.
Right.
Okay.
Through there.
Right.
That's how you figure it out. In other words, vertical shifts change that asymptote by whatever the vertical shift is. Okay? And now, if I want to draw that, I'll draw it in blue. Well, I know it has to go through that point right there. 1 comma negative 1. And I know it has to be asymptotic with that new asymptote.
Right.
So that blue line is y equals 1/2 to the x minus, I like this blue, x minus,
cool.
minus 2. Yeah, it's more visible. So that's the equation that I have drawn.
Okay.
With only 2 things happening. I've shifted the key point 1 to the right and 2 down. Now, let's take into the account the 4. What is the 4 going to do?
The 4, so shift it up 4.
First of all, what is the 4? Describe it as a transformation.
It's a vertical stretch by 4.
Okay, a stretch. That changes the shape of the curve.
Yep.
This point, what happens to it when you multiply it by 4?
It'd be 4 comma negative 4.
Hold on. I'm multiplying the x by 4. What does that
be 4
do
negative
y? Well, it doesn't do anything to the x. The x stays at 1. What happens to the y?
Turns into 4, negative 4.
Negative 4. You multiply it by 4. So this point that was there all of a sudden moves down to here. 1 comma minus 4.
Okay.
Now, that, hold on a second. Yeah, that changes that point. Because it's a vertical stretch, it multiplies that point by 4 and makes it go through here rather than where it went through.
Okay.
So the new curve looks something like that. Where's the new asymptote? Where's the horizontal asymptote? It was, in the beginning, it was y equals 0. And then we shifted it down and it was y equal minus 2. Now we're multiplying it by 4.
So would it be -8?
God, that is a terrific guess. I'm not sure what's right, to be honest. I have to think about this for a second.
Oh, you're good.
But yeah, you would multiply that by 4, which notice that vertical stretch factors do not change the x value at all.
Mm-hmm.
But they do change the y value.
Right.
So that instead of going through 1 comma minus 1, it now goes through 1 comma minus 4.
Yep.
Where does that put the horizontal asymptote? Where was the horizontal asymptote?
Y equals, wasn't y equals 0?
The pink.
Yeah. Parent function or the new one?
Pink. The pink was this.
Okay.
That was the pink minus 2.
Oh, yeah, I didn't see that.
Actually, the blue, let's look at the blue. I'm sorry.
You're good.
The blue is this function that I've circled over here.
Uh-huh.
The only difference between the blue and our final function is that stretch factor of 4.
Okay.
In other words, I got a vertical stretch factor of 4, and what that does is it takes every point that would have been on the blue and it multiplies it by 4. Well, we can see that we're way below the x-axis.
Yep.
So instead of 1 comma minus 1, that point goes to right there, 1 comma minus 4, but the horizontal asymptote moves down to minus 5. Because if I go through this point, which is 1 comma minus 4, I better have a horizontal asymptote that's below that, right? Because otherwise it doesn't make any sense. In other words, you would not be able to have a horizontal asymptote at y equal minus 4, because this point is at y equal minus 4. And the graph never touches the horizontal asymptote. Very big deal. You cannot touch the horizontal asymptote.
No.
Okay, so the horizontal asymptote must be 1 unit below this. Remember where that thing started at. That started at 0 comma 1, but we had a horizontal asymptote, y equals 0. So the horizontal asymptote is always 1 below that. Well, if we get our point down to 1 comma minus 4, then the horizontal asymptote must be at minus 5.
Okay.
All right?
Okay.
All right, Dylan, I am going to let you go. And let's see, let me make sure here. We just have one more session, right?
I believe so.
And that's
what's that tomorrow?
Monday night, nothing on Wednesday. Your test is Tuesday?
Our test is Wednesday.
Wednesday. Okay.
Yep.
Well, we'll have a session on Monday, and you let me know if that does it for you. My Tuesday is pretty booked up. There must be a lot of people taking finals on Wednesday.
Definitely.
But if it was an emergency, I could squeeze you in, Dylan.
Okay, sweet.
Let me know if you need a Tuesday appointment.
Okay.
At the moment, I will talk to you tomorrow night at 8.
Sounds good. All right.